Okay, look at this circle with these parallel lines and two quadrilaterals, QRSU, QRUSU. There's a quad right here, and another one, QRTU. And the center is right there at 0, and then there's chords produced that meet at P, and RT is parallel to QU, and we're going to need all that. Okay. They say that this angle right here, O1 here, ROU, O1, is 2x. Well, that's an angle at the center. And there's T1, an angle at the circumference. So T1 must be x. An angle at the center is 2 times the angle at the circumference. So if that's 2x, that's got to be x. Well, this S2 opens up to the same chord, the same segment where you are, the same segment of the circle. So that means S2 must be equal to x, angles in the same segment. Now, if that T1 is x, these are parallel lines. T1 and U2 are corresponding angles. That's because RT is parallel to QU. What one did I do next? Oh, yeah, Q2. In this quadrilateral right here, S2 and Q2, it's the exterior angle of that cyclic quad. So if S2 is x, Q2 must be x. And for the same reason, if U2 is x, then PRT is x. They only asked for 4, but we're going to use that one a little later on. Okay. By the way, if you're playing this game, you should have written in all the places where there were x's, because it's real important for the next one. They ask us to prove that ROUP is a cyclic quadrilateral. Well, I've done this question a few times and I keep forgetting. Usually it's angles in the same segment. That's not the story here. If these are two x's, then the angle P there must be 180 minus 2x. We know we were given in the beginning that O1 is 2x. Well, if these two angles sum to 180, that's one of the 3 ways you can prove that there's a cyclic quad. So P is 180 minus 2x because of the angles summing in the triangle. And if this is 2x and it adds up to this, we can say now that ROUP is a cyclic quad because the opposite angles in this cyclic quad are adding to 180. So it's the converse of that. Because they add to 180, you must be able to put a circle around ROUP. Okay, the last question is, can you prove that QR is a tangent line? Well, hey, QRP there, whatever T, that is equal to the angle x, and S2 is equal to x. Well, that means you could put a circle around there, and the angle between the tangent and the chord would equal the angle at the top of the triangle, the alternate segment. So, PRT equals S2. We proved that before. They're equal to x. Therefore, QR is tangent to MRS. And it's the converse of the tan chord theorem. Well, there's all of that done, and some of it was a little bit hard.